one student tell me I put the wrong number here, so I recalculate. So this is actually the answer for the pressure force. So the second question is, if we can find out where is the CP, like the open circle showing here. Okay, so the idea is, this is the hinge, and we have the CP point in here. Okay, so last class we know the FP values. If we can know the length of the CP relatively to the hinge point, but the question tells us we need to compute the normal force F. And if we know normal force relative to the hinge point is L, so we can make the moment balance for two forces, and then we can find out what is the F. Okay, so exactly we know L is equal to 5 meters, right? Because here the length is 5 meters. And we know the FP here. So until now, what we don't know is LCP. We don't know the LCP. So we can compute the LCP first, and then we can solve what is the F. So the idea, we follow the previous slide. We know the YCP. The YCP is the CP point here relatively to the 0 point here. So this is the YCP minus Y bar. So Y bar is the centroid point, the distance relatively to the 0 point here. So it's equal to I bar divided Y bar divided the total area. So first we compute the Y bar. What is the Y bar? The Y bar is the centroid point here, and if the centroid point relative to the hinge point here, so it's a 2.5 meter, right? In these directions, so the 2.5 meters plus 10 here, because the Y is relative to the reference point 0 here, so plus 10 meter. So the Y bar length start from here to here is 12.5 meters. And A is total area. So as we know, the total area is equal to pi 2.5 and multiply 2. Okay, so use your calculators. 2.5 multiply 2 and multiply pi. So around the 15.7 meter square. And the I bar is most important items for these formulas. So this is a highlight how to compute the I bars. And I noticed, I mentioned, you need to focus on what is the rotational directions. So as we know, the rotational direction is along the x-axis, and you can follow this formula. So you check, this is the hinge point. So the rotation direction is along the B, directions. The rotation is along the B directions. So we can simply follow this I bar formula here. So the I bar is 4 over pi, and A is the 2.5, 3 powers multiply the A is 2. Okay, so you can compute the I bar values. Okay, 2.5 power 3 and multiply 2 divided 4 and multiply pi. So the I bar is around the 24.54, and this is the dimensional unit is 4 power meters. Okay, so you can take the answers, put the numbers into the formulas. So the upper is 24.54 divided the y bar is the 12.5 and the area is the 15.7. Okay, so you can compute by yourself, and for me I just take a quick. So this is around the 0.125. Okay, this is around these numbers. So if you go back to see here, this is follow these numbers, we can determine the LCP length, because this is the numbers is the distance between the centroid and the CP. This is the number is between the centroid and the CP difference, and we just plus the 2.5 meters, and we can know LCP. Okay, so actually we can compute the LCP. LCP is the distance from the hinge and the centroid point is 2.5 and the plus, because here is the distance between the CP and the centroid point. So just plus the 0.125. Okay, so LCP is equal to 2.625 meter. Okay, so as I mentioned, we need to make the moment balance. So actually the FP multiply LCP should be equal to the normal force we didn't know right now and multiply L. Okay, so the F normal force is equal to the FP multiply LCP divided L. Okay, so we actually know that the answer showing here is the 1540. Maybe just I use the 0.95 K newtons. Okay, and divided. Sorry, no space. So LCP is the 2 multiply 2.625 and divided L. L is total. L is 5 meters. 5 meters. Okay, so you can determine the FP values. Sorry, there is no space, so I just extend to under. Okay, so you use your calculators. 1540.95 multiply 2.625 and divided the 5. The answer is around the 809 K Newton. Okay, so as the answer show in here, so the basic ideas, first we need to determine the FP, and the second we wondering to know where is the location of YCP. And then this is a very standard problems for engineering, because usually we put the gateway, and the gateway is would like to this is like the spillway to take the water flow out. But the idea when we design the structure like this, we need to compute the normal force which is required to open the gate. So this is very standard questions for the engineering design the spillway. So the two key questions, we need to find out the pressure force first, and the second we know exactly the YCP locations, so we can estimate the normal force is required to open the gate. Okay, so this is a very good exercise, and right now you know how to apply hydrostatic idea to the spillway design. Okay, so I need to go down, and not always the exercise we are for the plane, the flat plane. As I show the exercise here, the example, this is for the curve. If we change the curve surface, so how different for the force balance? So the basic idea is because the surface is not the flat, so we need to divide it, consider the questions, and we need to divide it the dimension along the x-axis and the y-axis. So we need to separate two directions and try to consider the force balance along the x direction and the y directions. So you see, this is an example. For these curvatures, the surface. So we consider the force along these directions, and second we consider the force along the y directions. So along the like the example showing here, for the AC directions, we have the force AC. The force AC is related to the water currents, like this, the water currents, to provide the pressures contribute from the water current. But if we consider the BC line in here, for the vertical force, first one is contribute to the water current in here, right? And the second contribute is from the self weight, because this is the fluid inside, so they will have the weight contributions. So we need to, for the vertical, not only we have the water, the force contribute to the water above the BC line, the second we still have the weight. Okay, so you can see there is a summarize. For the y direction, we have the weight inside, and the force CB, they contribute for the water currents above the BC line. But for the x directions, we only have the pressure currents, water currents contributions. Okay, this is for the, if you have the spherical circles containers, then always you can have some vapor pressures. But the vapor pressure usually quite smaller, right? As we mentioned before, because the vapor pressure contribute very small gamma values. So we didn't take a care for this. So only have the water, the fluid weight contributions in here. Okay, just I very quickly introduce. And this is also not the flat shape. This is a curved surface. And you need to overcome the water loadings. So that you can compute what the force is required to support these water loadings. And but if your curved surface is outside the waters, so how can you compute the force distribution along this surface? So we consider the water loading also. So extending inside is a water loading. Okay, so no matter you are the fluid is just above your surface, or the fluid not above your surface, you need to consider all of the fluid loadings based on your problems. Okay, so we just do this exercise, and you know how to solve these problems. So this is the surface AB, okay, and the radius is 2 meters, and please notice that the width is 1 meter into the papers. Okay, so we have the width 1 meter into the papers, and the distance is EB is 4 meters here. And then the fluid above the surface AB is water. So we know right now it's water. And the water surface is exposed at the atmosphere pressures. Okay? So the answers, we try to find out the answers. The question is, what is the magnitude and what is the 9 actions of the hydrostatic force? So I already put the answer on the buttons. So for these questions, we need to answer the force along the x-axis directions. We need to know the force along the y directions. And then we need to point out the location point for the f-axis and the fy. So you see the f-axis at this point, and the distance between two these points is these values. And the y force acting on this point, this is fy, and this is for the f-axis. So we need to know where is the length. What is the length for the fy and the f-axis? Okay? So that means we need to determine where is the location for fy and the f-axis, and how large of the f-axis and the fy. So as I mentioned, for this kind of the problem, you need to define the 2 dimensions first. So we start from the x directions, and for the x directions, this is this force, and then we focus on the panels along the AC panels. This is along the AC panels, because for the AC panels, the force is horizontal force. So again, first we find out the centroid point. The centroid point should be at the center. Okay, at the center here. So this is our 0 point, and the distance at the centroid point, this is Z bar, right? The Z bar. And then we know the radius is 2 meters. The radius is 2 meters. So the distance here is 1 meter. And the distance between the CD is 4. So totally the Z bar is the 5 meters. Okay? Since we know the Z bar, so we can compute the pressure force, right? So the pressure force is equal to P bar multiply total areas. and we know the D bar is gamma Z, P bar is gamma Z bar. The total area is, this is the circular arc, and then along the AC plane, should be its right angle. It's a right angle plane. Okay, so and we know the width is 1 meters, and the length, AC length is 2 meters. So the area is the 2 meter multiplied 1 meter. This is the total area. It's a right angle plate. So the gamma is the water, so 9810 multiply 5 meters, and multiply 2, multiply 1. This is the area, total area. So the answer is 9810, and this is 5 multiplied 2 is 10. So 0 Newton. Okay, so you can check the answers. This is actually is equal to the FA case, because we only have the force along these directions, along the x directions. So you check the answer showing here is correct. Okay, this is for the FX directions, but we didn't know how to determine the locations for this part. Okay, so the second question is we need to decide the CP location here. So as I mentioned, here we use the Z. So the Z, CP minus Z bar is equal to I, the second moment, divided the Z bar, divided the total area, right? As I mentioned, the Z bar we already know is 5 meters. And the area of the plate along the AC is the 2, length is 2 meters, and the width is 1 meters. So the area is 2 meters squared. And what is I? I bar, because this is a right angle, and the rotation axis is parallel to the width directions. Okay, so we know the second moment is 12 over width, power 1. So, and the length along the AC is 2, and the 2, the power is 3. Okay, so for this is the 8 divided 12 is around the 0.67. Okay, so we put this number into the formula in here. So we have a 0.67, and divided the D bar is 5 meters, and the area is 2. Okay, so the difference between the CP and the Z bar centroid point is 0.067 meters. Okay, so because the distance between the centroid and the C is 1 meters, and the distance between the C centroid and the CP is 0.0767 meters. So finally, we know the location here is 1 meters plus 0.067 meters. So the answer is 1.067 meters. Okay? Because we know the distance here is 1 meters, and the distance between the centroid and the CP is 0.067. So we can know the answers. Where is the location of the FX? Okay, so, but the seconds, we need to focus on Y directions. So for the Y directions, we are looking for the BC service line. So the BC service line is here. Okay? So first we need to compute the FV first, right? Because we know this the force is contributed from the water columns above the BC line. So this is water. Actually, this is the gamma waters, and the depth is the 4 meters. The depth is the 4 meters. Okay, and the area of the force, the area is along the BC. It's also the same. It's 2 multiply 1 meters, 2 meter length along the BC, and the width is 1 meters. So this is the volumes above the water volumes above the BC line, the BC planes. Okay, so this is 9810 multiply 8. Okay, so you can compute the answers is around the 78480 newtons. Okay, and how about the weight? The weight is the contributed from the water inside the ACB. Okay, the water volumes along the ACB. So this is the gamma multiply the volumes along the ACB, right? It's the volume along the ACB. So again, this is 98110, but the volume is, we can compute, this is compute the area first. So the area along the ACB is the pi radius square. This is a circle area, but we only have the 4/1 area. So this is the total area need to divide it the 4, because we only have the 4 area, and the height is the width 1 meters. So we multiply 1 meters. So this is total volumes along the ABC. Now, right now the R is the 2 meters. So we can compute the total volume, total weight. So this is 98110 multiply pi, and then multiply R square. R square is the 2 squared is 4, and divided the 4. Okay, so the answer is around the 30803.4 newtons. Okay, so we can compute the total Fy force, the force along the y-axis. So simply we just plus Fv with the weight. Okay, so you can compute the Fy first, 78480. So the answer is equal to the 109 point around the 8 kN. Okay, so this is, we got it because the answer showing here the same is the same. So we got it, but we didn't know where is the location for Fy. We didn't know where is the location for Fy. Okay, so how can we compute the Fy? So now this is the hinge point C, and we know this is B. We know the FV acting on here, and the distance, what is the distance? This distance should be the 1 meter, right? Because along CB direction, this is the symmetry panels, so the centroid point is at the centers. So we know the distance compared to C point is 1 meters. And we have the weight along these directions. So how about the distance between the weight force and the point C values? Okay? If you take a look for figure showing here, we know the centroid location inside the circles is this. This is a centroid point in here, but the distance between the reference point and the centroid point is 3/4 multiply radius divided pi. So we know exactly this distance is 3/4 multiply pi divided r. So this is the distance between the C point and the weight force. This is the distance. Okay? And right now, we didn't know the distance for the Fy. So we can make the moment balance. So first, we have the Fy, but we didn't know the distance between the Fy and the C. We didn't know. I used the L. But the moment should be equal to the Fv multiply 1 meters. This is a moment relative to the point C. And plus the weight multiply the distance in here. Okay, so this is the 3/4 and the pi divided r. Okay? So what do we already know? We know the Fy is 109.3 kilonewtons multiply L and equal to 78.5 K Newton multiply 1 meters. I just follow this, okay? Plus the 30.8 K Newtons multiply these items. So I compute this item, the number of these items. The 4 divided 3 and multiply pi and divided r. The r is radius 2. The r is radius 2 meters. So divided 2 is around the 2.09 meters. Sorry, there's no space. So you can make the balance and try to compute what is L, okay, by yourself. Okay, so actually the answer should be it's around 1 meters, but as just a number showing here, the answer is 0.957 meters. Okay, so for the curve surface is not convenient because we need to divide the two directions and solve the force individually for x direction and the y directions. And for this question, not only determine the force magnitude, we still need to determine where is the location for the force. Okay, so this is very normal in real case because usually we don't use the the flat plate because the normal force is the requirement of the normal force is large. But if we change to the curve, the force requirement will reduce. So that's why engineers would like to design the curve surface of the gauge, something like that. Okay, so yes. Okay, so yes, you are right. So just follow here. Just follow here is pi over r. Okay, thank you. Good. So you need to make the corrections. I wrong the formula is wrong here. So I make the corrections here. So and here. Okay, so we change. Here is a pi over r, and this is I can just use the 2 pi over 2. Okay, so the number will be changed. This is 8 divided 3 and divided 3 pi the pi. So this is the answer. Will change to the 0.849 meters in here. Okay, so you just compute it by yourself. Okay, so is compared to the flat surface. Is the difference is we need to divide the two directions to solve the problems. Okay, so this is one idea. Maybe it's I just very quickly to introduce the exercise. So as you see, this is follow the flat surface, but the exercise didn't want you to tell us the true answers. The exercise would like to just provide the final formulas. As you see, the reaction force at the A point here, reaction force at the A point here, and if your plate have the angle is 45 degrees, what is reaction force at the A point? So you see the reaction force is related to the gamma. If you change the different fluid, the force will changes. And the second related to the W. The W is the width of the right angle gate. And the L is the length of the right angle gate. So this is a general formulas for if you put the one flat panels under the water with the 45 degrees. You don't need to compute too complicated. You just follow this formula, and you can compute the force at the A point very quickly. But our question is B. If you change, initially the plate is along the AB is flat, right? If you change the flat surface to the curved surface, how changes in reaction force at the A point? So you only have the 3 options. First one is greater than, the second is less than or the same. So the idea for this exercise, because the waters above the AB curve is smaller than if you consider the flat surface. So you can answer the question very quickly, because we don't need to overcome large water loadings. So the requirement should be what are the answers. So I put this answer in our quiz highlight. So later you can answer the question by yourself. Okay, so I just start here, and for you, you can go back home and just derive the formulas like this. Okay, so now prepare your cell phone. Today I may stop here.